Computer. Oh, that was you. Okay. Oh, sorry about that. I didn't, you know, it's just a policy that we have. If your name has to match. Um, I had it one year where somebody brought a student in, they gave them the link, and the person wasn't supposed to be in the class. I guess they wanted them to experience what the class would be like. That's something you would have to meet with the professor beforehand and do. So sorry about that. To, I believe we're recording. No, I mean, all right. Here we go. We're going to minimize that. And we're going to go ahead and start the slideshow. All right. Ladies and gentlemen, here we go. Today is February 18th, 2025. I was about to say 26. We're not there yet. 2025, and this is your CDF110. This is your introduction to operating systems, and we're going to cover a lot of content. So, my objective on today is to cover two chapters and go over the content in those chapters. Now, as I stated last time, the importance of this course is that we're trying to gain the foundational knowledge of things that we would need to understand the career field of cyber defense. Now, the one thing about being an investigator, because that's what we are, a cybersecurity, we're customer service agents, we're investigators, things of that nature. But we investigate the network, we investigate computer systems, as well as we investigate anomalies that may take place on the network and issues and try to triage and troubleshoot certain things that may happen on the network from a forensics perspective. So, what I want to do here in this course is cover contents about the operating system, about hard drives, about storage media, about networking devices, about virtualization and security principles and concepts that we can use, as well as laws that govern these concepts as well, regulations, frameworks, so that we can make the best of a situation or, learn the foundational information that will help us to understand our career field a little better and some of the incidents that may take place. So, in chapter one, we're going to go into the following objectives. We're going to go into, sorry about that. We're going to explain the basics of operating system concepts, describe the categories of operating systems, discuss the primary roles of an operating system, discuss the five major operating system components, and we're going to talk about the history of operating systems as well as list several current general purpose operating systems. Trying to get the mouse to stop rolling so fast. So here's what we want to get into. That in order for there to be an operating system, there are certain characteristics that have to take place. You have input, processing, and output. What people don't also understand that there's networking as well as there's storage. That's a part of these functions as well. But that's for a computer system. It's not a computer if it doesn't input, process, output, store, and have some networking capabilities, which is why I often ask people, is a camera a computer, a digital camera, and they'll say yes, and I said no, because you have to take those photos and put them into a larger system to develop them and further process them. It's not just point and shoot anymore. But for operating systems or computer functions, you input, process, and output. So, in terms of computer hardware, there we do have some functions, but hardware is controlled and coordinated by the operating system. Now, one thing I like to show people, just to give them another basis of understanding, is that when we look up the kernel, which is the root of the operating system, OS, and we look at the image of a particular kernel, and this is just a theoretical image of a kernel for an operating system. Your kernel, which is the root of the operating system, if we come here, a kernel is the core part of an operating system. It acts as a bridge between software applications and the hardware computer. So if I ever ask you a question on an exam, what is the kernel? It is the core or the root of the operating system, where you have your core programs. To give you an example, we had an individual that worked for Baltimore City Community College in the IT department, and we would talk every now and then. He said, you know, you can build your own Linux. All you have to do is download the kernel from online, and you can build it from the ground up. So you can actually build your own operating system. The kernel manages system resources such as the CPU, the memory, and devices. This ensures everything works together and smoothly. This image represents that. The kernel controls software and hardware. Okay. Also, excuse me. Also, the kernel handles running processes, programs, accessing files, and connecting devices like printers and keyboards. The operating system includes the kernel at its core, but also provides a user interface. Now we have a command line interface, which looks as so. Uh, Whatever this blurb is, I got to get it out the bottom. Uh, Second. Here we go. We have a CMD. We have a command line interface as such as this. This is our command line interface, okay, where you can enter commands. Linux is like this a lot as well, or what we refer to as terminal. So you have your command prompt. All I did was type in CMD. I can right click and then access terminal. So if I access terminal, it's the same as the command prompt, but you have additional functionalities with this than you would with just the original command prompt. All right. So I'm gonna cut out of that. Then you have your graphical user interface, which is what we're looking at right here. This is our graphical user interface. This is what we call the GUI. And your cell phone has a GUI, your computer systems have a GUI, and that's so that the user has ease of use. And this was developed by Microsoft. Ease of use to look at certain and interface with the computer better. Right. All right. So, when it comes to that, the user interface provides a method of users to interact for users to interact with the computer system. You have storage management. This is a file system or a filing system, which is a method where the OS stores and organizes its files. Linux has ext, for Windows has NTFS as well as REFS. Mac has APFS. All right. Just to show you some things that you should kind of have, at your readily made sorry, disposal types of, sorry, filing systems. All right. So as you can see here in TFS, this is the default file system for Windows operating systems, supports large files, supports large files, uh, supports encryption, compression, and access control lists. Apple uses APFS or the Apple filing system developed by Apple for Macs, iOS, and other Apple devices. Optimizes performance and compatibility with Apple's hardware and software, includes file level encryption and improved performance on solid state drive. You had FAT or file allocation table. This was an old Windows filing system. Uses a file allocation table to keep track of file locations. The two major types of FAT16 and FAT32, often found on hard drives. All right. Linux uses ext4. Um, which is it said one of the most widely used file systems in Linux distributions and the successor to ext3 and provides several improvements and advanced features. HFS was on older Mac operating systems, and exFAT is really on hard drives or what we call extended hard drives. Uh, so that these are the different types of filing systems. Just to show you this image real quick, because I like kind of looking at that. You can see this is when we talk about filing systems, we often look at this structure. This is the same structure if you look at an organizational chart. So you have like your home or your home directory, your root directory, and then you have various directories that will come in after that. We'll get into that later when we get into the filing section, the chapter that's on filing systems. So you have user interface, you have storage management. Oh, you said the recording bar. And I don't know if it'll let me. I can put it in different places, but it's not going to let me minimize it. All right. Is that better?
Yes.
Okay, cool. Then you have process and service management. Process and service management is a program that's loaded into memory and run by the CPU. Now, when we talk about memory, we're referring to our RAM. Okay. A service is a type of process that runs in the background. So you have processes and services. So if you're loading an application or a program, you need to get familiar with the term process and service. Okay. If I was to go to this screen, let's go. I hate that it does this. It kind of won't let me view the icon at the bottom. So that's why I did that. I think that's why I'm trying to get here. So now I forgot what I was looking for with all that. Oh, task manager, right click, task manager. Oh, don't tell me y'all won't let me. I hit too many. Yeah, I did. But this is good. Y'all get to see a form of security. This is a security control. That so I don't access things that I'm not supposed to access. Okay, that's my password, buddy. So, oh, I can't get into it. So let's do this. Um, Task manager here. Go to task manager. All right. So if I click here and you see this image right here, we go to the task manager, scroll down to the image, just a tad larger. And we look here on this side right here, you'll see all the applications and processes that are taking place, kind of like we said last time. These applications and processes are the background processes that are taking place. Okay. All right. So that's process and service management. So it's good to get to know those things if you don't know them already. All right. So some more functions. You have memory and input output management. So your RAM, when it comes to things like storage devices that you would connect to your system, as well as when you connect things like keyboards, mice, the scanners, cameras, cell phones, that is also managed by the operating system. And the operating system must determine if sufficient memory exists to load in applications and where in memory it should be loaded. Okay. The operating system also ensures that input-output devices such as USB ports and video cards are accessed by only one process at a time. Okay. So we talked about last time there being cooperative um, processing as well as preemptive processing when it comes to operating systems. Another function of the operating system is security and resource management. Operating systems used on business systems provide methods for securing access to resources. This is where the term access control is very important. Here we go once again, the kernel. The kernel is the root or the heart of the operating system that runs with the highest priority. One thing I would like to show is something that is called kernel rings. Kernel rings. What's going on here? You're just acting like it don't want to work. I can't type. All right. Kernel rings. And I always explain this to my students because I want them to understand this. You have, they call them kernel rings, kernel levels, or kernel mode. And here are kernel rings. All right. These are images of kernel rings. You have, and ring, the kernel ring just means that if a certain section of the operating system is affected, then that could either affect rings three, ring two, ring one, or ring zero. If the whole computer shuts down, it's something that's taken place in ring zero. Move this here, ring zero. If something happens to, like the devices or hardware devices, then that could be ring one. If something happens to storage devices, that's ring two. And if something happens to ring three, these are applications. Now, when I'm talking about happening, or I'm talking about events such as your computer shutting down, or events such as an application that stops running, or issues with you storing to a hard drive, or if maybe your keyboard just stops working. You have different rings where these errors take place, and we refer to them as protection rings. I like to go to the this one right here. Yep. What are operating systems, rings, and operating systems? All right. So here we have the same graphic: ring zero, ring one, ring two, and ring three. Here's a description down here. Ring zero is the kernel, which is at the heart of the operating system and has access to everything and can access ring zero. If you have issues at ring zero, which is the kernel mode, your computer's going to shut down. Okay. Because here it says the code that runs here is said to be in kernel mode. Kernel mode processes have multiple or the potential to affect the entire system. Scrolling down, ring three is associated with applications. We call this the user mode, okay? Because user processes running in the user mode have access to ring three. This is the least privileged ring, and this is where we'll find a majority of our computer applications. And if there's an issue with applications, but it doesn't affect the computer because it's not in ring zero, the application may just hang. Then rings one and two, Here's what it says here. The operating system uses ring 1 to interact with the computer's hardware. This ring would need to run commands such as streaming a video through a camera on a monitor, or instructions that must interact with the system storage, loading or saving files, which are in ring 2. So storage is ring 2, ring 1 is hardware, ring 0 is everything. So if you get an error or a fault in ring 0, the whole computer shuts down. Then in ring 3 is mainly for applications. So know those protection rings as it relates to the operating system. Now, operating systems are in three different categories. You have single tasking versus multitasking. Single tasking is going to be, one task at a time. Multitasking is handling one task and multiple tasks or multiple processes taking place in the background. We have the single user versus a multi-user, and then we have a general purpose versus a real-time purpose for an operating system. So a single task operating system can execute only one process at a time. Apple ISO 3 and earlier versions are examples of these, as well as embedded systems like our gas pumps, our cash registers, kiosks. They can only do one thing at a time. Multitasking operating systems quickly switch between all the processes that are loaded into memory. That is like your computer systems, your cell phones, things of that nature. Cooperative multitasking, which we did talk about last time, is the operating system gives the CPU control to a process and waits for it to terminate or enter a waiting state. So, in other words, cooperative means that if the program does not give back control to the operating system, it may hog the CPU until its operations are complete. That's why sometimes you may have to go stop a process so that you can have another process running as well. No other program can run until control is given back to the operating system and is found in earlier Windows versions. This is cooperative multitasking. You may say, well, why are we learning about these things? You never know. We're in an AI generation. You never know what will happen, and you may have some computer laying around that you may have to use. I always give the example. Somebody got a question or comment? Okay. I always give the example of I have a friend who works for the government, and they did a scrimmage, red team, blue team, white team. Okay, the older gentleman on one of the teams used Morse code. He used old computer systems, and they ended up beating the younger team that used current technology because they could not see them or discover them. So you never know if you're going to be using those older technologies. You may get with an organization and they're still using Windows 7. It just depends on the company you work for. So then we have preemptive multitasking. It says the OS is in control of the computer at all times. So you have preemptive and you have cooperative. Cooperative is when the CPU and the operating system work as a unit. Then you have preemptive, where the operating system has total control and it looks over everything that's taking place. Here it says the running process can be replaced with another process at any time based on a system interrupt. As you're listening to me, concepts like system interrupt is something that you need to make note of. Okay, system interrupt, because we're going to go over those more in detail later, especially when you need to understand things like the CPU and the RAM are for processing, and when the CPU needs to um, process something else, it will move the process that is in waiting from the RAM to the hard drive. We call that swapping, where it goes from the hard drive to the RAM and the hard drive back to the RAM, or RAM to the hard drive and the hard drive to the RAM. So it says you also have a time slice timer expiring. So you have a certain time to use resources. If those times are up, that process has to wait. or go into a waiting state, go back to the hard drive or what we call virtual memory. Okay, so system interrupt, virtual memory. These are concepts that are very important because if you're going to be a forensic specialist, you need to know what files go back and forth. You also need to know what timestamps are on these files and folders, or you need to say, let me research the hard drive to see if there's anything on the hard drive that may implicate someone of a crime. Uh, the operating system has control over how much a computer's resources are allocated to each program. Computers must use more of their CPU and memory to support the OS, but the behavior of the computer is more predictable. All right, so the users can play music while working in documents as well as web browsers. So this is a visual representation of cooperative multitasking versus preemptive multitasking. You have processes here. Process one is at the queue, and it gives process one control of the CPU. Then the processor one does some work. The process one finishes, and as it finishes, it goes to process two. Then process two has control over the CPU, and as it goes through the process, it just changes once a program or a process is finished. Then the next process takes over. It's different for preemptive. One process may be running, and the time may run out, or another process may say, I need more resources. Then it's up to the operating system to make a decision if it's going to give more time to another process. But most of this is either from a system interrupt, or that's what I mean by if a program needs more time, it sends a signal to the CPU. The CPU communicates with the operating system. Then the operating system will look to see if there's resources or what programs it can stop to give another program more resources. And that's what this represents. And this is what your computer does over and over and over. Let's see if I can find a quick video to explain. Let's watch this one.
At Harbor Freight, we do business differently from the other guys. We design and test our own tools.
In this video, we are going to discuss the concept of swapping. We know that when processes are being executed, they are loaded into the main memory or the physical memory of the system. But a process can be swapped out temporarily out of the memory to a backing store. So what does swapping mean? That means this process from the main memory, it can be taken out and another process can be brought into its place. So swapping is like a kind of an exchange. So one process is taken out and another process is brought into the memory. So where is this process which is swapped out taken? It is taken to a backing store and then it is brought back into the memory for execution. Now this swapping, it improves the utilization of the main memory because in place of this process which has been swapped out, a new process can be brought in. And these swapped out processes, they are stored in the swap space, which is also known as the backing store, available on a fast secondary storage disk. This backing store is large enough to accommodate copies of all memory images for all users. What are memory images? That means the processes which are available in the main memory. These main memory processes or images can be put in this backing store. So this backing store must be able to provide direct access to these memory images when they are to be retrieved back into the main memory for execution. So this is also referred to as the swap out or swap in or the roll out or the roll in process. Now this swapping variant is used for priority based scheduling algorithms. So in case a high priority process is to be brought into the main memory, a lower priority process can be put out on the backing store so that this new process can be loaded into the main memory. So here's a broad overview of the swap in, swap out. If we have the main memory and the user space is having few processes, one particular process P1 can be put out onto the backing store, and in its place another process P2 can be brought in into the main memory. We know that the physical address space which is available in the memory of the system is limited in nature. So swapping, it makes possible to use this limited space so that it kind of feels that we can exceed the real physical memory of the system. So this increases the degree of multiprogramming in a system because now new processes and more processes can be accommodated in the main memory by swapping out the existing processes onto the backing store. Now when these processes which are in the swap space, when they are brought back into the main memory, is it necessary that they come back to the same physical address? Now this depends on the address binding method. If address binding was at compile time or at load time, then it is not possible to change the physical address. But if the physical address binding is at runtime, then it is possible to change the address of the process when it is swapped back into the main memory. The system maintains a ready queue of all the ready to run processes which have memory images on the disk so that they can be put back into the main memory when required. The major part of the swap time is the transfer time, and this transfer time is directly proportional to the amount of memory which is swapped. So the size of the process which is swapped into the swap space, the size of that particular process will determine the transfer time or the swap time. Now if the next process which is to be put on the CPU is not in the memory, then we need to swap out a process and swap in the target process. So the context switch time in this case can be very high. Let's say there was a 100 MB process which was to be swapped to the hard disk and the transfer rate is 50 MB per second. That means the swap out time will be of 2 seconds because it is 50 MB per second. If the swap out time is of 2 seconds, and let's say the process which is being brought into the main memory is also of the same size, then the swap in time will also be 2 seconds. That means the total context switch swapping time would be 4 seconds, which is comparatively pretty large. Nowadays, standard swapping is not used in the modern operating systems, but it is swapped. This process is used only when the free memory becomes extremely low. So if the free memory which is available falls below a certain threshold, then only the swapping will be used. And nowadays the modern operating systems use a variation of swapping where rather than swapping out the entire process, only certain pages of the processes will be swapped out. So a page out operation moves a page from the memory to the backing store, and if a page is brought from the backing store to the memory, it is referred to as a page in. So rather than swapping out this whole process back to the backing store, what can be done is to swap out certain pages of the process which are currently not being used. Like you can see in this example that page B, C and E of process A have been swapped out and put into the backing store. Similarly, in its place, we can bring in page F, H and J of process B back from the backing store to the main memory. So this is how the swapping helps us to increase or utilize the main memory in a better way.
I'm here, everyone. Hopefully that made sense. All it was explaining was that the operating system at some point, if it's not going to use a certain process, it's going to move it to virtual memory. Okay. And virtual memory is on the hard drive. So from RAM to hard drive. So this is an operating system CPU relationship where in preemptive, if certain things are not being used, if certain processes are not being used, they're going to move them to the hard drive. Okay. Let's kind of go back. Put a yes in the chat if that made sense. If it didn't and it's still a little foggy, put I don't understand it that much yet. And as we go along, it's going to make more and more sense. All right. So here we have a single user versus a multi-user operating system, and we explain that. With a single user operating system, it can only do one process at a time, run one program at a time. Earlier Windows versions did that. It says Windows 10 and earlier Windows client versions are arguably single user systems. So one user, one device. Okay. Multi-user operating systems allow multiple users to sign in to it, start and stop processes, interact with the user interface, and access the local file system. Linux, Unix operating system have always supported multiple users. In other words, these are server-based operating systems. So we have single user and server-based operating systems. Moving forward. So you have real-time versus general purpose. General purpose operating systems provide a convenient user interface and run applications in a home or business environment with reasonable performance, like our computer systems that we use right now. Real-time operating systems are designed to process inputs and produce outputs in a very specific and repeatable amount of time. It's a Real-time systems perform tasks like controlling assembly line robotic systems, controlling FedEx sorting facilities, managing the electrical grid. Components of real-time systems are called deterministic because it is possible to determine the worst case response times under a given set of conditions. So we know when a car is going to break down, typically in that third or fourth year, or in the sixth year, which is why your car payment is normally paid off in the sixth year. Because by the time you own it, it's broken, unless you take good care of it. But in relating this to what we call I6, and I6 is just this concept right here. Give me 1 second. I6, IS, CS. I think I did that right. What is an ISIC? All right. All right. So basically it's an where you can share cyber threats or for different organizations, or as we ICS, I'm sorry, ICS is what we're referring to, not now. And cyber, I should have put cyber. All right. So it's an industrial control system is what we're referring to. So when you have industrial control systems like your heating, HVAC, your heating, ventilation, and AC as well, those systems are now automated and run by computer systems. Okay. Our power plants, our water systems, they're run by computer systems now. So we really have to study those and monitor them to ensure that we are, you know, make their real time, so we have to know when products and parts are going to break down. All right. So here's a question for you. In which of the following methods does the operating system give CPU control to a process and wait for it to terminate or enter a waiting state? Single tasking, preemptive tasking, multi-user tasking, or cooperative tasking? CPU has control to a process and wait for it to terminate or enter a waiting state.
Can I take a guess?
Go right ahead.
That's a cooperative, correct?
And I believe you are correct. Cooperative. Uh,
Um,
cooperative. Yeah. And so in which because now you have a relationship between the CPU as well as the operating system. So you are correct. All right. So the roles of the operating system. The roles of the operating system are as follows. You have certain roles to play depending on the user. So you have client-based systems because we have to service the client. And when and then we have the server and standalone. Some people haven't, they don't understand this concept. So I often use this analogy. If you're at home and you want to play a game, which I often do sometimes, I will go to the Steam network and I will go to their servers and I will purchase a game as opposed to going to GameStop and buying it for an Xbox or a PlayStation. I play games on my computer. I think it's cheaper and it's easier, you know. Plus, I don't have to buy a new one every 5 years. You know, I don't get too hopped up on gaming systems, even though I do like them and they look sleek and nice, and they have multi features because you can stream on them as well as watch movies. And go on the internet. They're basically computers. They're little computers. You do everything with them. But you have a client relationship, which I would be the client in that scenario, and the Steam network will be the server. I want to access their server systems to gain access to the computers on their network or the games that's on their network. Then you have a standalone operating system like embedded technologies, gas station pumps, cash registers, things of that nature. So, client operating systems, they run applications requested by the user and request data from the network servers as necessary. Client operating systems are usually installed on desktop or laptop computers as well as mobile devices. Um, Give me 1 second, y'all. I have to handle something. So, give me 1 second.
Wix gives you the freedom to tell your story.
That client review was brutal.
We're gonna be underwater for weeks.
I'm already so pruny.
This is fixable.
Hi everyone, welcome to Gnan Cloud Garage.
This is Ravikiran from Ravi.
Hi, welcome to In and Around Computer. In this video, we are going to see the types of server operating systems. First, we can see what is a server operating system. This is specifically designed to run on servers, which are nothing but the specialized computers that operate within a client-server architecture to serve the requests of client computers on the network. We have a number of videos on what is a server, and you can check my videos on that. And the server operating system help enable and facilitate typical server roles such as web server, mail server, file server, and database server, application server, and print server. So these operating system facilitates these roles of the server. And now in this video we are going to see the types of server operating systems. First type is the Windows server. This Microsoft developed the Windows operating system family for everyday personal use and also professional use in servers. This Windows Server OS supports enterprise level management, data storage, and a vast array of applications. And this Windows Server features virtual memory management, a complete desktop GUI experience, allows multitasking, and supports various peripheral devices. The cons of this Windows Server operating system are the need for user-based licensing and more virus security threats compared to other platforms. So this is about the Windows Server operating system. Next type of server OS is the Linux, and this is a family of Unix-like operating systems that have all the features of Unix, and this is open source, available for free, facilitating multi-user, multi-process, and multi-threaded operations. And some of the most popular Linux server distributions are Ubuntu Server, Debian Server, Fedora and Arch Linux, etc. And these advantages of this Linux server OS are a high security, wide variety of distributions, integrated open source software including high level language compilers, and the ability to control the system using a graphical user interface. And the disadvantages are the lack of long-term support for some distributions and certain complex operations such as system updates. Next type of server OS is the Red Hat Enterprise Linux, and this is a paid Linux desktop and server distribution created by Red Hat. And initially this RHEL, that is Red Hat Enterprise Linux, was released as the Red Hat Linux Advanced Server, and it was later renamed as Red Hat Enterprise Linux AS, that is Advanced Server, which include two distributions. One is the Red Hat Enterprise Linux, that is AES, and Red Hat Enterprise Linux WS, that is for workstations. And the pros of this RHEL, that is RHEL, is the Red Hat Enterprise Linux, or the extensive support and available patches, upgrades, and solutions for security vulnerabilities. And the cons of this RHEL are the expensive training courses and the lack of personalized solutions. And the next type of server OS is the Unix operating system, and this was a time share. In the beginning, this Unix was a time sharing operating system for small computers, and over time it has become one of the most widespread client server environment operating system. And the pros of this Unix are a multi-user environment, built-in TCP/IP support, and high level of stability and security. This downside is that is paid, and different vendors sell different Unix version, and there is no standard Unix version. So this is about the Unix operating system. And next type of server OS is the NetWare, and this is a server based network operating system that includes a dedicated server to function. And this NetWare has pros which are the support for multi-process and large capacity physical memory management, as well as the top-notch file sharing and printing function in corporate networks. And this also offers a wide range of management interfaces, including web interface. And the cons are price, poor support, challenging installation process, and low third-party app support. And next type of server OS is the Mac OS server, and this is a Unix-like server operating system based on Mac OS developed by Apple. And this OS builds on top of the Mac OS and adds server functionality and the system administration tools, as well as tools to manage Mac OS and iOS devices. And these pros are the easy administration, that is good graphical user user interface and great support and easy workload distribution across multiple machines, and this is easy to increase the processing power. And the disadvantages are that the macOS server only runs on Apple hardware, which can be pricey, and also while Apple implements open source software in its system, there are changes specific to macOS requiring working around some issues which are not present in Linux. Next type of server OS is the FreeBSD, and this is an open source Unix-like operating system. This maintains a complete system delivering the kernel, drivers, utilities, and documentation, and includes an extensive server-related software collection. And this is easily configured as a mail server, web server, firewall, etc. And this advantages of this FreeBSD are that it is fast and good security, that it utilizes firewall, and had a lot of tools available owned by the FreeBSD team. And this disadvantages are that it is not very easy to learn since it has a poor community support than Linux and lacks driver support also. Subscribe to my channel if you feel contented. Like and share my videos with your friends.
Optera is the IT painkiller. Remote monitoring and management, remote access, help desk and ticketing, smart.
What is a client operating system? The computer desktop is a standalone computer processing unit. It is designed to perform automation tasks for people. A desktop computer is unique because it does not require any networks or external components to operate. The client operating system is the operating system for computer desktops or portable devices. This operating system is typically different from centralized servers because it only supports one user. Smartphones and small computer devices contain a client operating system. This operating system manages the components of the device, including printers, monitors, and cameras. Each computer typically has a specific operating system. Some computers can use multiple operating systems. This is considered a dual boot configuration. When a computer is built in this manner, it can be configured to run specific devices for each operating system configuration. This provides flexibility for software that is operating system specific. Having two operating systems gives the user more access to complex software programs. Many computers today connect to central servers on the internet by using telecommunication software. These central servers run many popular social networking programs including Twitter, Facebook and MySpace. The operating systems of the central servers are typically different than the local client operating system. These computers do not require operating system compatibility because they share information with special network software. Today there are many forms of operating systems designed for client computers. These include Windows, Linux, Mac and Android. Each operating system is designed to function on specific hardware. This hardware compatibility is one of the primary considerations when selecting an operating system for client computers. There are many freeware versions of Linux available for desktop computers. This client operating system provides multi-processing power at minimal costs. Most Linux operating system configurations require specialized system engineering knowledge. This installation process is not designed for the novice computer user. Windows is one of the most widely used client operating systems today. This operating system became popular with the introduction of Windows 95. Most businesses use the Windows Office suite for word processing. This software will not function without the Windows operating system. The Windows operating system requires special hardware that is designed to support this application.
What is a server? We sometimes hear that the server of any website or business organization is down or busy. We are familiar with these kinds of words, which are related to the word server. We know the word server, but many of us may not know how it works. In this video, I'm going to explain.
All right, let me stop this for a moment because they draw these things out just instead of getting to the point. I'm going to get to the point. So that's a client-server relationship. Your servers provide all the applications and resources, and the client systems or computers, or what we refer to as workstations, request the services from that particular server. That takes us into networking. This is why it's good. I always tell my students, please get to know your networking protocols. When I talk about networking protocols, I'm talking about, let's go here, ports and protocols. It's always good to know your ports and protocols. Here are some ports and protocols, if it ever populates. There we go. Here's just a few. I'm gonna build my own website. Oh, this is Medium. Medium's a good website. All right, so here are ports and protocols. When we say a port is really like access to a server. So there has to be an FTP server for you to send files via a files transfer protocol, using that protocol. So to access that server, you need port 20 over the network. It's like a door to the network. That's what I always tell my students. Ports are doors to the network. Think about your house. To get into your house, someone had to drive to the address of your house, and then they had to open the door to your home. Once they open that door, get in and close the door, they have ported into your network. Think of your sci-fi mind when we go from one dimension to the next, or when Thanos was with Nebula. She's in one dimension, and then she's in also in the dimension with the Avengers, and he had to go light years into the dimensions and through light and travel till he got to that dimension to get to that Nebula because she was snitching and telling secrets. So yeah, these are the doors to the. That's just my sci-fi mind, everybody. So you have a different protocols, and these protocols have a what we call instruction as far as how messages are going to travel or what server or service that will be provided on that particular server. So hypertext transfer protocol is associated with web servers. So port 80 is what you'll get here. Hypertext at the bottom where it says HTTP with secure socket layer, you'll see there's port 443. If I click on the top of my web browser and click here, you get the security information, because if I double click back into the website, you'll see in the browser we're using HTTPS. So all of our web traffic is secure and encrypted because it's going through HTTP secure socket layer, which in most cases is really TLS. But this will sound like gibberish until you learn this chart and learn what the ports and protocols actually do. So this is a great Medium page for you, but a lot of our textbooks is going to have this information as well. Okay. So client, server. All right, let's move on. Server operating systems. They provide, you share network resources and provide network resources to clients. Examples of servers, OSs include Windows Server, Mac OS Server, Unix, and many Linux distributions. Server OS usually come with a DHCP server, that stands for Dynamic Host Configuration Protocol servers, and a DNS server, Domain Name System servers. We'll get to know what all these terms mean later on in this course. A file server protocol, web server, and perhaps a directory services such as Microsoft's Active Directory. Typically, when I have these classes and we're face to face, some people are engaged, some people are not, because some people don't like to get into the weeds. They're like, "Oh, just let me work." But no one's going to let you, if I had a company, you will not touch my servers unless you know that network in and out, unless you can communicate that network and the understandings of that network, because your goal is to secure the network. If you don't understand what the DHCP server is, what a router, a switch, a hub, a rogue router, a rogue DNS, if you don't understand all the things that could possibly happen to the network, and no one's going to allow you to be in that situation. Okay. So it's your best to know everything that you can about a lot of things, because you never know the area that you're going to be in if you get a job in cyber, because it's so expansive. Like we used to call it information support systems. They just scratched that name, and now it's cybersecurity. So you have IT and you have cyber. And when we say IT is normally associated with coding and programming, there's security and programming as well. And then you have cyber, which is about protecting the systems. You don't necessarily have to know coding, but if you do know coding, it is an asset that can really help you. All right. Server operating systems have certain functions built in. Fault tolerance, the ability of a system to recover from a hardware or software failure. OS server types support clustering. Now, we talked about clustering last time. This is when you have more than one server that acts as one. So they're going to cluster together. Load sharing, or what we refer to as load balancing, is when you have two or more servers that alternate between taking requests from clients. So if it was me and another teacher here, and that teacher was handling a different set of students, and I was handling one set of students, we're load sharing. Okay. And so hot swapping is the ability to take out devices and the computer system still be running. Like I often tell people, I had a coworker at another job. He used to work for SunTrust Bank, and his main job was to go into the data center or the server room and listen to see if there were issues or problems with the hard drive. Then he would remove the hard drive and replace it with a new hard drive, and the hard drives would repair themselves. So he had to monitor the server room. That's called hot swapping. Then we have scalability, which is the ability to add additional computers or different components of a computer while we are working. That's scalability, the ability to grow or scale. You can scale up and you can scale down, but there's a different term for scaling down. Server operating systems, with these, the hardware of a server must support fault tolerance, such as hot swapping and failover clustering. And that just means that if one system fails, the other system is there to be a backup. Server hardware can take different forms, including traditional tower computers, rack-mounted servers, and blade servers. Does anyone have a question at this moment? If so, please put it in the chat. Then we have standalone operating systems, or what we call embedded systems. Our kiosks, when we want to renew our driver's license and we go to MVA, the Motor Vehicles Administration, when we get there, you can either go to a desk, you can either wait, or you can go to the kiosk. But the only responsibility of that device is to ensure that we renew either our driver's license or in most cases, our registration and our license plates. Okay. These OS systems that run older or isolated traffic signal systems are likely to be standalone. This is changing as computer controlled devices are being built with Internet of Things in mind. So operational and performance data for these devices can be collected and analyzed to make processes more efficient. So the main thing that we kind of focused on last time was the booting process. I wanted everyone to know that, because I will be asking questions about the booting process. Process and server management, memory and input-output management. security and resource protection, as well as the kernel. You have to understand these questions and these concepts because you will be asked to explain them, not just define, but explain. I want to know that you know what they are, the components of an operating system. The booting process or procedure, we talked about that. Power is applied to the CPU, hardware components. The CPU starts, the CPU executes the firmware startup routines. The operating system is located by the firmware. The operating system is loaded into RAM. What is the operating system? It's the kernel and all associated applications and your startup applications that are going to be loaded into RAM when you hit that power button. You have the OS processes as well as services that are started as well. Firmware. What is firmware? It's a program code that's stored on your computer in a non-volatile memory, which means it can't be destroyed when the computer's turned off, and it's responsible for performing diagnostic tests, which is called the post. You have non-volatile memory, which is our non-volatile memory. As I said, keeps its contents when the power is not on, and we refer to it as an EEPROM, which is electronically erasable programmable memory, or programmable read-only memory. And this is mainly in older systems. We have NVMe, different types of chips that we use now. So the firmware is either called the BIOS, basic input output system, or the UEFI in newer systems. So let's do this before we go there. It says firmware contains an initial bootstrap program that locates then loads the bootloader program, which is responsible for loading the initial process that makes up the operating system. I'll say it again. You have a bootstrap program that looks for the bootloader program, and the bootloader program finds the operating system and loads it onto RAM. Let's do this real quick. I wanted you to understand BIOS versus UEFI. In terms of definition, basic input output system, and UEFI is Unified Extensible Firmware Interface. Let's get a quick video. Of course, there are tons of them. Try to find a good one.
Most Planet Fitness clubs are open 24 hours, so you can work out whenever.
We're coming in early. Staying.
Today I want to discuss UEFI-based BIOS. First off, UEFI stands for Unified Extensible Firmware Interface. And now you understand why everybody just calls it UEFI, because it's a mouthful. In order to understand what UEFI BIOS is, we need to understand what BIOS is in general. So first off, all computers have some sort of motherboard, which just allows all sorts of peripheral devices, including your CPU, storage disk, memory, keyboard, and much more, all communicate with each other through basically a data bus or a mess of traces on a circuit board. Anyways, we're not getting into that magic, but BIOS is a piece of firmware that usually exists on something like a EEPROM. You don't really need to know what that is, but let's just think of this as some memory that resides on the motherboard and helps your computer start up, and it does just a few basic things, such as 1. Confirming your hardware is okay, pointing to an operating system, runs some basic drivers for things such as display support, and 4. Allows you to change some hardware settings. Of course, that's not all that BIOS does, but are some of the more important things, at least in my opinion. And now that we understand what basic BIOS support is, we'll talk about 2 types of BIOS. 1 being UEFI, and 2, which had been the most predominant type of BIOS, was MBR BIOS, which now is known as legacy BIOS. So since we're focused on UEFI, we're only going to talk about what benefits UEFI brings to the table versus MBR, legacy BIOS support. We all know what the 2 screens look like, but UEFI has a better user interface, typically allowing you to even use mouse support and can give you a better overall experience, including even animation support. Number 2, UEFI-based BIOS comes with faster boot times. Now, you can't give all the credit to just UEFI based BIOS, but it's technically optimized because it's a newer BIOS model compared to MBR legacy BIOS and supports faster interfaces, making things inherently faster. There's also larger disk support. Basically, MBR based BIOS used to support up to 2 terabytes of storage space on a storage disk before it theoretically couldn't work anymore. But with UEFI based BIOS, we have nothing to worry about because we're starting to get into petabytes of data before we run out of support. UEFI BIOS also supports network booting, which is great for enterprises because you could literally boot into your computer, server, or what have you from a network rather than a local disk. This is, of course, useful for production or enterprise environments that have diskless workstations or thin clients being used, meaning we're just not accessing things locally. You don't have direct access to a terminal or monitor in order to actually boot into your system. So these are 4 of the biggest advantages to the unified extensible firmware interface. And most of us, whenever we purchase a new computer, we're going to get UEFI based BIOS. You'll notice a night and day difference between MBR and UEFI, especially when using UEFI for the first time. It looks like a much more modern interface, even though that on some systems it can be lackluster. I know Dell has a very nice interface when it comes to their UEFI based BIOS, and these are some of the benefits on why UEFI based BIOS is just a better choice when it comes to modern systems. Number 5, the last one I want to talk about, is security. There's just more built-in features to keep your computer secured, including special checks, which today can be controversial. If you want something to check out TPM, and how newer versions of Windows operating systems require you to actually have this support for your processor, and it has to be enabled through BIOS if it's not already. Either way, hopefully you learned a little bit about UEFI BIOS today. If you did, let me know in the comment section below. Also, let me know some other things you know about UEFI BIOS and share it with the rest of us, because I couldn't get to everything quite today. But hopefully this is a good primer. Also, subscribe below.
All right, so that covers some aspects about the UEFI firmware as well as the BIOS firmware. BIOS is related to, it's a firmware chip that sits on the motherboard. And this chip in computers from 2013 and prior, like 1996, 1997, up to 2013, used the BIOS. Computers from 2013 to now use the UEFI. And there are great differences between the both of them, right? Here we go. BIOS has the following functionalities and descriptors. You have it's a chip on the motherboard. It initializes input and output devices. In other words, if you connect a hard drive, you have to format the hard drive. If you connect a keyboard, you have to download the drivers for that keyboard. It performs what is called a power on self test. Provides a user interface to allow hardware configuration, such as CPU overclocking, as well as it locates the OS and the interfaces with the user. That interfaces with the user. You have a CMOS chip, which is a complementary metal oxide semiconductor, and this battery is for keeping time. This CMOS chip used to be what we referred to as the BIOS, and configurations were stored there. It's a little different now. Users can make changes to the BIOS configuration by accessing the BIOS setup screen. When the PCs turn on, the machine wakes up, begins executing this program. It tests keyboards, hardware, initializes hardware disks, and other devices, and the main operating system is then loaded. A process is a program that's loaded into memory and executed by the CPU. A program can be a user application, an OS service, or even the kernel. Windows 10 systems, you see all the processes running in Task Manager, as well as you can see the background processes. All right. Here it just says Windows processes are required for full system functionality and include the registry service, user interface components, network services, and the interrupt handlers. This is an image of Task Manager, which I showed earlier. And I broke down kernel mode versus user mode already when we talked about the kernel rings. User mode is going to be for your applications. Kernel mode is going to be for everything, your hardware and software devices. Here it says a process has unrestricted access to the computer hardware and access to privileged CPU instructions. In user mode, you only have access to memory locations that have been allocated by the operating system. Okay. So this is why they talk about preemptive and cooperative to get you to understand these concepts and the difference between kernel mode and user mode. You have a process creation and termination. All processes are assigned an ID, and that's called your process ID, which allows it to communicate with other devices, kind of like your social security card, okay, or your social security number. A file handler is an identifier for a file that contains all information the file system needs to locate and access the file. In other words, it's like GPS. So you have location or trackable information. When you create a file, a bitmap is created in UEFI so that when certain files need to be located, the operating system doesn't have to look all over the disk. It just looks in that file and finds out where the disk is. Or I'm sorry, where the actual file is. The operating system does that. Processes are usually created in one of four ways. You have the bootloader through a request by the operating system, by another process, or by a user. You selecting an application or something like that. Memory and output management. We're talking about RAM. We're talking about solid state drives. We're talking about all kinds of things that are associated with memory, even virtual memory. So memory is managed by a dedicated memory manager, or we call it a memory controller. And this runs in the kernel. When a process is loaded and started, the operating system must allocate enough memory for a particular process. This is why when your battery goes dim, when your battery's going weak, your screen may go dim because the operating system says, we don't have enough resources from some other application, so let us dim the screen so that we can use those power resources. When a process terminates, the OS must mark the memory as free so other processes can use it. Yeah. Input output management is, and you're like, oh, computers do all this? Yes, they do. You have input output management, and it's required to prevent more than one process from accessing an input output device at the same time. So you have checks, just like your messages have a timer. If you're going to send me a message and someone else is going to send me a message, your message has a timer to make sure that your message has a priority and gets to me at an intended specified time. All networking devices are listening. They're listening on the wire, just like you're driving down the road and you're paying attention because you don't want to crash or collide. Your messages don't want to crash or collide either. So memory and output management, if you take a look at this graphic, you have your monitor driver code and you have your disk driver code. User mode drivers, these are user mode. Remember we just talked about in the kernel, the Ring 3 applications. You have your monitor device driver, you have your hard disk device driver, and you have your CD, DVD, ROM drivers as well. These are kernel mode because they are hardware devices. All right. So then you have your hardware, your video cards or your network interface cards, your graphical user interface cards, your hard disk controller, then your monitor, your hard drive, as well as your CD-ROM. And here, we're trying to really get you to understand a device driver, software that allows the kernel to control hardware. A device driver is usually a kernel mode process that accesses hardware devices directly on behalf of user mode processes or other kernel mode processes. So, since those instructions are being made, the operating system says, I'm going to allocate those resources as needed. All right. So, remember I told you to hold on to that term interrupt? This is why. Because there are certain interrupts that will take place that will tell the operating system that another program or process needs resources. So you have polling, a process where the operating system checks each device one after the other in a round robin fashion to see if it requires attention. So the operating system is always checking devices or processes or programs to make sure that their time allotted is either used up or what's the status, so they'll know how to make changes if need be. So it's because of the shortcomings of polling, most systems use interrupts. Interrupts is a signal usually generated by an input-output device that alerts the CPU and operating system that a device needs attention. Okay, so an interrupt, say like I need to print a document, and I'm on the internet, I'm doing everything. The program or process that's associated with my printer will send a signal to pin 1 of the CPU so that the CPU can tell the operating system we have an interrupt request and we need to allocate resources so that my printer can print. So that may mean swapping some things off of RAM so that you have enough allowable resources for your printer to print a document. If that's clear, put a yes in the chat. Everybody still here? Can y'all hear me? All right. We just got Marco. So the other two people, y'all aren't here. All right. So here it says pins on a CPU are usually called interrupt request lines. Oh my goodness. Missy Elliott just popped into my head. Hold up, please. I'm on the request line. Music. I can't help it. When the CPU detects the interrupted request line, it stops what it's doing, determines the source of the interrupt, and starts execution of the interrupt service routine, or the ISR, also referred to as the interrupt handler. Okay. Interrupts are prioritized. Critical system devices such as a system timer have the highest priority. One thing I got to say about cyber, if you do not like to read, if you do not have an investigative mind, this is not the field for you. You have to investigate. If you want something, you got to search and go for it. This is honestly a field where you don't need a formal education if you know how to search and research for information. I lost somebody? But the whole point of the formal education is advancement, promotion, because some businesses won't take you unless you have some form of education. There's some positions, a CISSP, if you don't have a bachelor's degree, you're not getting in that particular job. All right. So a software interrupt is called a trap and can be generated by user mode programs when they need intermediate kernel service or immediate kernel services. To prevent unnecessary interrupts, ISRs turn off interrupts of equal or lower priority, and this is called interrupt masking. I'll read that again. To prevent unnecessary interrupts, ISRs, which we call the interrupt service routine, um, turn off interrupts of equal or lower priority. This is called interrupts. In other words, it's saying not right now. You can't get access right now because your priority is not as high as the one we have that's currently taking over. And then you have what I call, if you look here, if you can go into system information and to access system information, you can do MS Info 32. If you went to go here and escape out of this and minimize this. Hate when it does this. There we go. You did a Command R, Control R. I won't let it come up. Windows R. There we go. MS Info 32, which is the system information of your computer. And as you can see here, now you have system information. So that's one way to get to system information by typing You hit your Windows key and R, and you get the run dialog. Or you can just type in the search bar, type system info, and there it is. And you can open up in the same way. And then you get information about your hardware resources, your components, your software, and it's just a plethora of information that you can find here. Then we have ways that we protect information. So, operating systems and real-time operating systems running on embedded systems can provide controls to prevent unauthorized access. So we use authentication, which may be your username and password. Then you have authorization, verifies where you have permission to access certain folders and files. The kernel runs with the highest priority. Scheduling computer processes and managing resources are key tasks of the OS kernel, and jobs performed by the kernel can include the following: interactions between the CPU, interrupt handlers and device drivers, basic computing security, use of the computer's memory, and assigning priority levels to programs and computer processes. All right, here's knowledge check two. The ability of two or more servers to act as one is known as which of the following?
Um, the ability of two or more servers to act as one is known. I would say maybe hot swapping.
Actually, hot swapping is the ability to keep your system running and to remove components, such as a hard drive, and then replace it with another one,
Mm.
which would be similar to hot adding. Bootstrapping is really a program that looks for the operating system. So clustering would be it. And clustering is just when you have, let's say we have two servers that handle the same thing, we would cluster them together to act as one so that it could handle more requests. Clustering. This goes into the history of operating systems. Give me 1 second to see how much time we got. Just to talk about the history of operating systems. Really. All right. So all it's gonna say is it started from typewriters to you had your big clunky mainframes at some point. The dawn of the internet was in the late 60s. Scientists from everywhere and colleges came together to create a way of communicating. Um, Even you had, what did they call it? What is it? The cold winter, something winter, AI winter, where they tried to create AI in the late 1960s, and it just didn't happen because they didn't have adequate computer resources. But they came up with Unix, uh, Unix operating systems, which is associated with certain mainframes. You had programmable languages, which were developed. You had BASIC, beginner's all-purpose symbolic instruction code. It says in 1975, Bill Gates wrote a compiler, software that turns computer code written by people into code that is understood by computers. For BASIC, he sold it to a company called Micro Instrument Telemetry Systems, or MITS, which became the first computer company to produce a desktop computer. And other programming languages around this time included Pascal, C, and other versions of BASIC. And I think you got Visual Basic as well, or VB. Um, Bill Gates started a new company called Microsoft. They never mentioned the other guy, the actual programmer. Bill Gates was like the marketing guy, but the other guy was the programmer. Um, let's look that up real quick. Who started Microsoft? with Bill Gates. Paul Allen. There we go. Paul Allen co-founded Microsoft with Bill Gates, the two childhood friends. These people didn't even finish college. They dropped out of college. Look at these guys programming these big things. I know a guy, his father never went to college. He's a NASA scientist. It's crazy. I'm not talking badly about college. I'm just saying if the right person mentors you and they teach you, you don't need it. But in most cases, we can't find mentors that are gonna anyway, I don't want to speak negative. So Paul Allen was the guy. Okay. IBM adopted MS-DOS, and MS-DOS was created by Microsoft. Uh, a prototype of a new computer, because IBM was made the first mainframe back in the 30s, being developed by, and those were like calculators. IBM called the personal computer. So IBM developed the personal computer. Microsoft DOS was first widely distributed operating system for microcomputers that had to be loaded from a disk or tape. In 1984, Apple developed a GUI and a mouse pointing device, which allowed users to interact with the OS on a graphical screen. In 1985, Microsoft released Windows, which provided a GUI and many of the same functions as the Mac OS. So these two companies have been going back and forth for years. What is the general purpose of operating systems? You have Windows client operating systems, Windows server operating systems, Unix and Linux operating systems, and Mac operating systems as well. The biggest or most frequently used client systems for Windows were Windows 7 and Windows 10. Yep, people love Windows 7 and they loved Windows 10. The most popular server operating system for Windows Server is 2012, 2016, and 2019. And when it comes to Unix, Unix is the predecessor to all of these operating systems. You have many flavors of Unix, just like in Linux, you have many distributions, or we call them flavors as well. But the two are Berkeley Distribution Software, which is from Berkeley University, standard, and the System V Release 4 or the SVR4 standard. So Linux OS is a Unix look-alike system that is popular as the server OS in business, education, and government. Mac OS for Apple Macintosh devices is, they say popular in education, but I'm like, what education? I most mainly see PCs unless you have design schools. Anyway. Corporate users sometimes regard macOS as difficult to set up for networking in medium-sized to large organizations. Apple addressed these concerns and is popular with home users, and it's very intuitive. And in summary, computers have input, processing, output. The OS provides a foundation in which computers can execute programs or applications. The basic task of the operating system is to perform input-output functions, basically control hardware and software. And the OS can be understood in terms of characteristics such as time sharing, real-time operation, and multi-user capabilities. Early OSs or operating systems were single task, but now they're mostly multitask operating systems. Multi-user systems are one in which multiple users can access it, and a single user, you can only use one single computer at a time. You have two types of operating systems, your desktop client or your server operating system. You have your BIOS and UEFI, which is the firmware that looks for the operating system as well as checks system components. It is located on a firmware chip called the EEPROM chip, which is a non-volatile chip, which means that if the computer is powered off or there's a fault, the instructions still stay on that chip. Device drivers give functionality to hardware devices, basically software that controls hardware, and the kernel controls that. And lastly, you have a number of different operating systems from single user computer systems to desktop systems and you can run them on large mainframes or small PCs. You do have your graphical user interface, but you also have a command line interface, which I did show you when I typed CMD, and we also mentioned the most popular operating systems for Windows and Mac systems as well. Ladies and gentlemen, that is chapter 1. Chapter 2 we'll cover on Thursday. Are there any questions or concerns? All right. So I want to ensure that everyone, I'll be grading assignments, and I'll make sure that everyone has all of their materials. Once that is done, I will update anyone if they have not completed or have not shown up to class or anything like that. If there are no further questions, class is dismissed.
Not from me.
All right. Thank you, Marco, for your participation. I truly appreciate it.
Welcome.
All right, everybody. Y'all have a great one.